In this video, we're going to do a few extra examples involving circles and their equations. So the first example is on the next page here. It's to find the x-intercepts when we have the equation of a circle in standard form. So the equation here is x plus 2 squared plus y plus 3 all squared equals 36. So we want to find the x-intercepts. Okay, so the x-intercept means that we're going to set y to be 0. Okay, so that means I'm going to have x plus 2 squared plus 0 plus 3 squared is equal to 36. So that gives me x plus 2 squared is equal to, plus 9. So 3 squared is 9 is equal to 36. So if I subtract 9 on both sides, that's going to give me x plus 2 squared is equal to 27. Okay, now you could expand and then try to refactor, but it's actually easier if we use the square root property. So if we take the square root of both sides, keeping in mind that we need to add plus or minus, then I'm going to get that x plus 2 is equal to plus or minus the square root of 27. And 27 we could actually reduce, so this is good practice maybe. Okay, so if I subtract 2, x is going to be negative 2 plus or minus the square root, and 27 is 9 times 3. So that means that it's x is negative 2 plus or minus root 9 times root 3, and root of 9 is 3. So we get x is negative 2 plus or minus 3 root 3, okay, as our x values. And both of these are x-intercepts, so our x-intercepts, remember we should give them as points, are negative 2, the x value, one of them is negative 2 minus 3 root 3 combined with 0, and this I'm going to write approximately equal instead of equal. So if you want to make a decimal, this is negative 7.16 approximately. But you should always give it as an exact answer. And the other one is going to be negative 2 plus 3 root 3 with y equals 0, which the decimal you should get is approximately 3.196. Okay, so those would be our answers, our x-intercepts for that circle. Okay, so then there was a couple more to do where we want to turn, first we want to turn one into general form or standard form from general form. Okay, so here we almost have a general form equation except that there's a coefficient in front of the x squared and the y squared. So luckily it's the same coefficient, because if it wasn't we would get something else. But so we can make, so what we're going to do first is factor out this coefficient. Okay, so that's going to be 2 times x squared plus y squared minus 6x plus 4y minus 12 should equal 0. So I took out 2 from everything, and now I can divide both sides by 2 to cancel it on the left. So I get x squared, I'm going to put the x's together, so x squared minus 6x plus y squared plus 4y minus 12 is going to be equal to 0, because 0 divided by 2 is still 0. And now what we want to do is complete these squares. Okay, so we complete each of them. So to do that, the x1 is going to be half of negative 6, so negative 3. So it's going to be x minus 3 all squared, which means I need to add, so I take these two terms, but then I want to add negative 3 squared, which is 9, and also subtract 9 so that I haven't actually changed anything. Okay, now for the y's, half of the 4 is 2, so I want to take these two terms, but then add 2 squared, which is 4, and then so I have to subtract 2 squared, which is 4, and then I still have the minus 12. Okay, and then if we just put brackets around these 3 and these 3, those are going to make perfect squares. Okay, that was the point of adding those numbers. So this one is x minus 3 all squared, and then I have that minus 9 still. And then this one is y plus 2 all squared, and then I still have that minus 4, minus 12. So moving everything around, okay, so we keep this guy here. I'm going to rewrite x plus 2 as, or sorry, y plus 2 as y minus negative 2. Okay, and then all these numbers put together gives me negative 25. So I'm going to add 25 to both sides. Okay, and that's going to cancel with all of those. So this should be equal to 25. So then we can, so now we're in standard form. Okay, so now we know the center of our circle is going to be 3, negative 2, and the radius is going to be the square root of 25, which is just 5. Okay, so now we can easily read the center and the radius for this circle. Okay, so one more example. So we want the standard form of the circle that contains the point 4, negative 2, and it's centered at the origin. Okay, so centered at the origin means that my center, HK, is actually 0, 0. Okay, so we already know the equation looks like x minus 0 squared plus y minus 0 squared is equal to r squared. So that means that x squared plus y squared is equal to r squared. Okay, so we need to find r. Now, if I just draw a little picture here, okay, so here's my axes. Oops, that's not x, that's y. Okay, so here's the center of my circle, and then I know that the point 4, negative 2 is on there. 1, 2, 3, 4, 2. Okay, so this point here is on my circle. Okay, and if that's the center, that means that this distance here is the radius of my circle. Okay, so the distance from the circle, from the center, to any point on the circle is the radius. Okay, so then the radius, r, is the distance between the points 0, 0 and 4, negative 2. Okay, so we can find that using the distance formula from section 2.1. So it's going to be the square root of the difference in the x values squared plus the difference in the y values squared. So that's going to be square root 4 squared is 16 plus negative 2 squared is 4. So it's going to be the square root of 20. Okay, now 20, oops, let's do it here, is 4 times 5. So that means that it's square root of 4 times the square root of 5. Okay, and the square root of 4 is 2, so it's 2 times the square root of 5 is our radius. Actually, I didn't need to do that because I want the radius squared. So our equation in standard form is going to be x squared plus y squared equals the radius squared, which you can take from here. So this is r, so r squared is going to be 20. Okay, so that's our equation that's centered at the origin and has radius square root of 20. So it goes through the point 4, -2. So that's just doing a few things with circles and their equations.